Good morning, students. In chapter first, after studying about the Newton first law, Newton second law, now this is the Newton third law of motion. According to Newton third law of motion, the every action has equal and opposite reaction. What does it mean? It means if you are applying a force on the wall, suppose you are punching on the wall, and you are just punching here. What will happen? You also get hurt. Why you get hurt when you punch on the wall? Because when you exert force on this wall, this is called the action. This wall also exert equal and opposite force on your hand, that is called the reaction. And due to this reaction, we get hurt. According to Newton's third law, there is for every action there is equal and opposite reaction, and this is called the Newton third law. And you can write the Newton third law, that is, whenever one body exert whenever one body exert a force on another body like this, you are exerting some force on the wall, है ना? So you are exerting the force on the wall. The wall is also exert equal and opposite force on your hand. This is called the action. This is opposite force which is exerted by this wall is called the reaction. So on another body, the second body means this another body. The second body exert an equal and opposite force on the first body. Okay, is it clear? So this is the Newton's third law of motion, the law of action and reaction. The force exerted by the one body on the other is called the action, and the opposite force exerted by the other body on the first one is called the reaction. So we can say the force exerted by the first body, the force exerted by first body on the second body is called action, and the force exerted by the second body, I think it should be clear to you, that is, I explained you that the force exerted by the one body is action and the opposite body is the reaction. So the force exerted by second body on first body is called reaction, and first body is called reaction. Okay, clear? What is action and what is a reaction? The action and reaction are always equal but act on the opposite direction. If you are exerting, suppose you are exerting 5 Newton of force on this wall, then this wall is also exerted on you the equal force, that is 5 Newton, but in the opposite direction. It means we know that force is a vector quantity, so we can say this force is plus 5 Newton, then force exerted by the wall on your hand is minus 5 Newton. So this is called the law of action and reaction, Newton's third law. One thing you should know, that the action and reaction always act on different bodies. For example, if someone asks you, suppose if I ask you, I'm asking you that we know that action and reaction are equal and opposite. We know that action and reaction are equal and opposite. I explained you the action is always equal to the reaction, but in opposite direction. So we know that the action and reaction are equal and opposite. Then why they do not cancel out each other? It's a very interesting question, why they do not cancel out each other. बहुत क्लियर सी बात है ना कि आप इक्वल एंड अपोजिट फोर्स है, यहाँ से भी इतना फोर्स लग गया, यहाँ से भी अपोजिट फोर्स उतना ही लग रहा है, तो दे शुड कैंसिल आउट ईच अदर. देयर शुड बी नो अनबैलेंस्ड फोर्स हियर. देयर शुड बी अ बैलेंस्ड फोर्स ऑन द ऑब्जेक्ट. So why they do not cancel out each other? This is a very interesting question for you. I think I don't want to I don't want to answer this question. If you will ask me this question, then I will explain you why they do not cancel out each other. And this is a question for you, why the action and reaction do not cancel out each other. There are some example of the Newton third law. First example, you can write the application of Newton third law, or you can say the examples of Newton third law. First is, how do we walk? How do we walk? You know how we are able to walk? These are your feet. Suppose these are your foot. What happens? What happens when you walk on the floor? You push the floor with your foot. Same as you push the floor with your foot. This is called the action. And according to Newton's third law, this floor also exert equal and opposite force on you. This is called the reaction. And due to this action and reaction, we are able to walk. अब सोचो, आपने धक्का लगाया फ्लोर को, फ्लोर ने उतना ही धक्का आपको भी लगा दिया. That's why you move forward. So you can write the explanation, how do we walk? Write down the explanation here. When we walk on the ground, then our foot pushes the ground backward. Backward. You push the ground in backward direction. This is called the action. This is the action which is performed by you. In return, the ground pushes our foot sorry foot हो गया ना, our foot forward, and this is called the reaction. And due to this reaction, we are able to move on the ground. Okay, clear? And what will happen? One more question for you. Why we are not able to move on the slippery floor, or we can say if there is a banana peel on the floor, then why we don't able to walk on the floor? Or if there is a oil on the floor, or it means it can be a ice on ice, you can't able to walk. So what happens if you walk on the slippery floor? Why you're not able to move on that type of floor? This is a question. One more question for you. Okay, now again one more question for you, that we know that we are exerting the equal force on the floor, and the equal force is exerted by the floor on our foot, but the acceleration produced on the objects are not equal. Suppose the floor is not move at all, but you moves forward. So what is the reason behind it? Why the same force is not able to produce same acceleration on the objects? So this more question is for you. Now the second example of the Newton third law. Why, if you have any problem in the questions, you can ask me in your group, in your WhatsApp group. You can ask me, so that I will know that you are seeing the video and you have getting some problem, and I will really sort out your problem. Okay, why the gun recoil? This is the next example of the Newton third law. Why the gun recoil? आपने कभी अगर गन शूट किया हो, स्काउट गाइड वगैरह में किया जाता है वैसे, तो नोटिस किया होगा, या फिर जहाँ पे जो मेले वगैरह होते हैं वहाँ पे भी होती है गन, तो you have noticed that this gun recoil means it make a jerk on your shoulders. So why it make a jerk on your shoulders, or we can say why it recoil, why this gun recoil? Now I'm going to explain you, just try to understand it. This is the bullet which is fired from the gun. What happened when this bullet is fired from the gun? This gun exerts some force on the bullet. That's why this bullet moves in the forward direction. And we know that according to the Newton third law, there is for every action there is an equal and opposite reaction. So when this gun exert a force on the bullet, this bullet also exert equal and opposite force on the gun. That's why this gun recoil. But the velocity of the bullet is much higher as compared to the gun, because we know that gun has a higher mass than the bullet. That's why this gun recoiled. It means the gun moves in a opposite direction to the bullet, but with a very small velocity, because it has a more mass as compared to the bullet. So you can write the explanation here. When a bullet is fired from a gun, the force sending the bullet forward is equal to the force sending the gun backward. It means some force is exerted by the gun on the bullet, and this equal to this force, the bullet is also exert the force on the gun, but in the opposite direction. Since the gun has a higher mass as compared to the bullet, so its recoiling velocity is much less as compared to the bullet. You can write down here. When a bullet is fired from the gun, the force sending the bullet forward, we can say this is action, is equal to the force sending the gun backward. This is called the reaction. But due to high mass, the gun, due to the high mass of the gun, it moves only a little distance. Since it is in opposite direction, so we say it recoiling of gun. Little distance backward. Okay, now more examples of the Newton's third law. Next one, about the flying of a jet. The flying of jet plane or rocket, the flying of rocket, suppose. First, you should understand, in case of rocket, what happens. Suppose this is a rocket. We know that a lot of gases evolve from this rocket, which is produced by the reactions in the rocket, which is produced by the burning of the fuel in the rocket. And this gases which is produced in the rocket is pushes in downward direction towards the earth. So a lot of gas is exerted from the rocket in the downward direction towards the earth. This is called the action. It means this rocket exert the force on the ground, and according to Newton's third law, this ground is also exert equal and opposite force on the bullet. This is sorry, not the bullet, this is a rocket. Equal and opposite force on the rocket, and this is called the reaction. And due to this reaction, since the force exerted by the rocket on the floor is much higher, it means a large amount of force is exerted by the rocket on the floor, so that the force exerted by the floor on the rocket is also in a much higher quantity. And due to this reaction, this is by this force which is exerted by the floor on the rocket, this rocket is able to move in the upward directions. So how this is the working of the rocket, how the rocket work. Yeah, the how the flying of the rocket is can be explained by using the Newton third law. So you can write here, in a rocket, in a rocket in a rocket, the hot gases produced the hot gas is produced by burning of fuels rush out rush out of a jet rush out of a jet at the bottom of the rocket. Okay, lots of gases exerted is uh, is uh, is rushes out from the rocket. Okay, I'm writing here, rushes out of the jet at the bottom of the rocket, at the bottom of the rocket at very high speed. At very high speed. Okay, and due to this high speed, we know that the force exerted by the rocket on the floor is in very large quantity. Uh, this is called the action. The equal and opposite force is also exerted. The equal and opposite, it is going to be boring, I think, huh? But this is really important. It really worth. An equal and opposite equal and opposite reaction force of the downward the equal and opposite force of the downward going gases pushes the rocket upward with great speed. We know that we can change the speed by applying the force, or the much force, the large the quantity of force, large is the quantity of the acceleration produced, or you can say the speed acquired by the object. तो आप ज़्यादा फोर्स एक्सर्ट करके क्या करते हो, ज़्यादा स्पीड एक्वायर कर सकते हो. So this is about the Newton third law. These are some examples of Newton third law. One more example. In case of boat and a ship, I don't know you observe or not, when you moves out of a boat, this is a boat, and if you moves out of the boat, this is a shore, I think this is the river bank. When you moves out of the boat, this boat moves in backward direction. So what is the reason behind it? When we push this boat in backward direction, this boat is also push us in forward direction. It means the force exerted by us on the boat is a action. This is the action, and the force which is exerted by the boat on us is a reaction. And due to this reaction, we are able to move out of the boat. So you can write it yourself that how we are able to move out of a boat. Next one, In case of a pipe, I think you have seen ever in your television or in reality. This is a hose pipe which is used by the in fire brigade. इट मीन्स बहुत ज़्यादा कहीं आग लगी होती है तो बहुत ज़्यादा पानी बुझाने के लिए बहुत सारा पानी चाहिए, तो ये जो होता है होस पाइप, दिस इज कॉल्ड द होस पाइप। व्हेन द यू हैव टू होल्ड दिस होस पाइप वेरी टाइटली, एंड दिस इज आपको आपको कहा भी जाता है कि बहुत इसको टाइटली पकड़ना है वरना ये आपसे छूट जाएगा। तो ऐसा क्यों कहा जाता है? बिकॉज व्हेन द वाटर्स कम्स आउट फ्रॉम दिस होस पाइप, this is the force exerted, this can be the action of the this can be the action, पानी बाहर आ रहा है, this can be the action। और जब पानी बाहर आता है it makes an equal and opposite, is exert an equal and opposite force on the hose pipe, so this is called the reaction, and due to this reaction the hose pipe can move in randomly in any direction, so we have to grip it tightly, we have to pick it tightly, this hose pipe, that's why uh, it don't move in any direction or anywhere else. Now next, more examples about the Newton third law. There are lots of examples for the Newton third law. In case of the horse pulling a cart, horse pulling a cart, what happens actually? When a horse pulling a cart, this is the horse, I can't make a horse, this is a horse and this is a cart, okay? What happens? The horse has 4 legs, so the horse exert the force on the floor, and the floor also exert the equal and opposite force on the horse, and this equal and opposite force, this reaction which is exerted by the floor on the horse, should be greater than the friction force which is applied, which are applying on the wheels of the trolley or cart. It should be greater than this friction force. So the force exerted by the horse on the floor, when the horse exert the force on the floor, this is action, and in opposite the floor is also exerting equal opposite force on the horse, which is a reaction, and due to this reaction the horse is able to move this cart, because we should know that the cars has also the friction force on its wheels। देखो जब ये हॉर्स इसको चला रहा है तो व्हील्स पे फ्रिक्शन फोर्स भी तो लग रहा है ना, तो खाली हॉर्स को दौड़ना नहीं है, उसको दौड़ने के साथ इसको अपने साथ खींचना भी है। तो अब इसमें कौन कौन से अपोजिट फोर्स काम कर रहे हैं? ये फ्रिक्शन फोर्स एक्सर्ट हो रहा है व्हील्स पर, और तो अब इसको इतना फोर्स एक्सर्ट करना पड़ेगा कि जो रिएक्शन फोर्स है वो इस फ्रिक्शन फोर्स को भी ओवरकम कर जाए और ये आगे हॉर्स भी मूव करता चला जाए। तो दिस इज़ अबाउट द हॉर्स पुलिंग अ कार्ट। तो दीज आर द एग्जाम्पल्स ऑफ न्यूटन्स थर्ड लॉ, एंड दिस इज ऑल अबाउट द न्यूटन थर्ड लॉ। There are lots of questions for this law, and in next video we will study about the conservation of momentum. This was the last part, it will be the last part of the chapter, and after that the chapter will be over. Okay, bye.